Hello, good morning, everyone. Welcome to another chatting around campfire. In this episode, we are going to interview Daniel Nilsson. Thank you, Daniel, for being available to chat with us.
Thank you for inviting me.
Well, Daniel was professor in the Lund University. He is from Sweden. And now it's living on New Zealand. He is now teacher in the Canterbury University, and also he is consultant in the fire research group. So that said, I would also like to thank everyone that is attending this chat today, and say that attendees can make questions in the comment box in both YouTube or Facebook. So you can ask questions in English, or you can ask in Portuguese as well, and I will translate to English. So with that said, the first time I've been in Sweden, I went to attend the SFP International Conference on Performance-Based Design Codes and Fire Safety Design Methods. That was in 2010, hosted by the Lund University, where you have been teacher. And in that conference, there was a large group of people coming from New Zealand, speakers and attendees, and they were very joyful and very noisy. And there was a clear contrast between Swedish people and people coming from New Zealand, so completely different ways of living. So you are Swedish, why moving to the antipodes from Sweden to New Zealand?
That's a good question. It probably started about 20 years ago when I was an undergraduate student at Lund University, and I got the opportunity to study one semester at the University of Canterbury. As a student, it was a very attractive option to study one semester abroad. And I really loved it here. I loved it in Christchurch and at the University of Canterbury. So after working at Lund University for a very long time as first a PhD student and then a lecturer and senior lecturer, and this opportunity to become professor at the University of Canterbury popped up, I thought it would be a good opportunity, take a chance to move back to Christchurch. And to be honest, if I would not have tried it out once as an undergraduate student, I most likely would not have moved to the other side of the world. But since I knew Christchurch a bit, since spending time here, I thought it sounded like an interesting option, also a good option for the family, for the children to learn English. So they go in English schools here. Before they knew a bit of English, but now they're fluent in English. So it's a good opportunity for the whole family.
Okay. So, in 2006, I think 2015, I went to Copenhagen for the first European conference, SFP European Conference on Performance-Based Design Codes, and I attended a course, a very short course, 2-day course, lectured by you on evacuation for fire safety engineering. And you mentioned that in that course that there isn't such a thing as panic, and you even showed a very interesting case study based on a fire drill in the Simpsons, in the nuclear power plant. That was really funny. And I think this concept of there is no panic, it's in a way something that, you mentioned more than once So my first question will go, and this is not truly my question, is also a question that, well, I asked Guillermo Hein to ask some questions, because we do that with previous invited people, to ask them to ask questions to the next one. So the first question that Guillermo asked is, I still read journalists referring to human behavior in emergency as panic. What is panic, and why is invoked so often? So this is not my question, but I would do it anyway.
Yeah, that's good. Well, I think it's not a matter necessarily of panic if it occurs or not, if it exists or not. I think it is the misuse of panic, and also the fact that panic is often used assuming that everyone knows what you're talking about. So I would definitely say that the Hollywood version of panic, that you hear fire and everyone starts running around and you get a crowd crush, that is definitely a myth. When it comes to panic as a concept, if panic occurs or not, I guess it depends on how you define it. One of the best definitions, in my view, is one by Quarantelli. He derived his definition based on studying case studies. He looked at a lot of cases to see how people behaved, and he found a couple of behaviors that he called panic. And based on that, he found a definition of panic by looking at these case studies. So Quarantelli's definition, it's a long definition, but it's an acute fear reaction, marked by loss of self-control, which is followed by non-social and non-rational flight behavior. And that, in my view, is quite a sensible definition of panic. In many other definitions, you use irrational, so that people act irrationally. What we see in fire situations is that people don't really act irrationally. Irrational would be having the perfect information and acting in contrast to that, in opposition to that. So you're acting against what you know, and that we simply don't see. What we do see is that people do get very, very stressed and sometimes make simplified decisions. So, and also we've also seen that people, they are not antisocial. Some definitions include antisocial, but people are not antisocial. But we do see if they're highly stressed, they lose the fact that they're there with someone. So you lose sort of the concept of social bonds. So in the station nightclub fires, there are reports of people holding hands. And then as the fire and flame went above their head, they let go of someone. But that is not the same as the sort of Hollywood version of panic, which would be that everyone is scared, they start running, and they die in the exit as everyone tries to get out at the same time. That simply doesn't happen, at least not in modern times. Instead, people might be temporarily stressed, and acute in the definition of panic is very short. So we're talking 10 seconds maybe, which is short enough to not actually create a problem on ground level. Now, the second part of the question, I guess, is why does it reoccur all the time? Why does media refer to panic all the time? I think part of it is selling newspapers, since panic sounds very attractive. It's a key word that makes people read it. But there is also the fact that people, if you look at yourself and I ask you, would you panic if I told you there was a fire? The answer is typically no. If I ask you, would that person, randomly chosen, would they panic? You say, well, I'm not sure. They might. Since you don't understand why they're behaving the way they are, you see yourself as a logical individual, but you can't understand why everyone else is behaving the way they are. And often people tend to label the things they don't understand, like, why did that person do this action? I don't understand. They acted totally irrationally, and I call that panic. So it's sort of inherent to human nature, I think, that you label the behavior of others that you don't understand as panic, since from your perspective, you don't understand why they did what they did. But from their perspective, they typically have a good reason for it. But it is interesting, since I've read literature from all over the world. So Cold War literature from the US and Russia, where you didn't really, or Soviet Union, where you didn't have a lot of communication, both mention panic. You have references from the UK. So it's sort of a fundamental trait of humans that we don't understand how other people behave. And if we don't, we think they act irrationally. And our only explanation would be, well, they probably panicked. But they typically have a good reason for acting the way they do.
As eventually, it sometimes is also a way of authorities saying it wasn't their fault. It's like an excuse.
Yeah, it ends up being used at that in some cases. So you use it as a scapegoat. So if you can blame panic, then it's basically the people themselves who are to blame for their behavior, rather than poor building design or inappropriate number of exits. But it is an oversimplification. It's better to instead look at the situation, see what information people had and how they made decisions. Since it is never the people's fault if you have, for example, a crowd crush situation, which more often, it's very rarely due to panic. It's more often a flow problem. So that too many people, too few exits, that's a crowd crush situation.
Well, this course that I mentioned in Copenhagen in 2015, well, after attending the course, I like it very much. So I invited you to come to Portugal and lecture a similar course, a little bit shorter. And I believe that now you are lecturing another one there in New Zealand. So there's a time gap between that one I attended in 2015 and now. So my question is, what has changed in evacuation for fire safety engineering in these last 5 years?
One major development, apart from you collect data and you get more data all the time. So we learn more and more about how people behave in fires, and we get a richer data set. But I would say if one of the major developments in the area is the use of virtual reality. So before we did a lot of experiments in the field, we did a lot of experiments, traditional lab experiments. Now what we often do and what we're working a lot on is using virtual reality and virtual reality experiments to build geometries that we weren't able to test before. So anything from unbuilt underground stations that have not yet been built, where we want to see if a certain evacuation system works or if it doesn't work, or we want to refine an evacuation system. It is now possible using virtual reality. And these virtual reality experiments are becoming more and more realistic. We're not at the point of feeling like you're 100% there, but we're getting very close. And it is a relatively cost-effective way of doing experiments, since once you have your building, your virtual building, you can change systems, you can recruit new people, and test new designs in a relatively simple and straightforward and cost-effective way.
Okay, so I've looked into your bio in the University of Canterbury website, and you have there a very pretty interesting list of topics of research interest, and I'm going to read it. Okay. Human behavior in fire, emergency evacuation, wayfinding systems, emergency notification systems, evacuation modeling, and pedestrian dynamics. Well, that's a very interesting line of research, and you are very enthusiastic with your research. So I'm going for each of these topics, make you a small question.
Okay.
Not this one. Sorry. I'm having a problem here in my computer, but it will soon be fixed. Okay. First one. So the first one is concerning human behavior in fire and evacuation modeling. I put the two together. How can we model it? So how can we model human behavior? You gave some tips already. how can we calibrate the model without a real scale, real fire test in which occupants are truly exposed, and as we do on CFD models. And I will put here some extra questions. The thing is also, for instance, when you feel the smell of fire, smell of smoke, then your brain starts acting differently. So how can we create this and replicate this without killing people? No one wants that.
No, that's a tricky question. We're sort of bounded by ethics as well, so we can't expose people to anything. Part of the data we can probably get from real fire incidents and doing interviews with fire survivors. But I think we can get quite far by just doing unannounced evacuation drills. And the main reason for that is that for most buildings that are evacuated, the majority of people, they don't see the smoke until they're exposed to fire smoke. And by that point, it is to some extent too late. So a lot of the evacuation is actually done without the fire smoke and exposure to fire. Since if we do a fire engineering design, we should ideally have people evacuate before the exposure is too severe. So what we're doing is one level of realism that we're trying to achieve is that when we're collecting data, we try as far as possible to do unannounced evacuations. So people are not aware that they're taking part in an evacuation drill. It's just an alarm that starts in a building. And hence, it is not that different from an alarm starting in case of a real fire. For those people who are exposed to fire smoke and how fire smoke changes their behavior, I'm not sure we have that much data, but at the same time, it's a smaller part of the population. And my guess is that if anything, that would make them respond quicker and move a bit faster, is my estimate, until they're sort of overcome by smoke and the toxicity plays a major role. But if it's just smelling smoke, for example, they probably move faster. And the approach there is to use the pre-movement times we have already for non-smoke situations. Since if we use that, and in our engineering analysis, we can still show that the building is safe or they have time to evacuate, then in a real fire, we would be even safer, since they would move quicker. So often you sort of use conservative values rather than spot on perfect values when people are exposed to smoke. Since from an ethical point of view, we will struggle to do experiments and get ethics approval if we expose people to dangerous conditions.
Okay. So concerning pedestrian dynamics, this is something that we read a lot recently in social media. Does COVID social distancing really impacted pedestrian dynamic, or the effect is neglectable?
This is something we don't know yet. Actually, New Zealand is a bit unique since we currently don't have COVID-19. So it's one of the few places where you can actually do crowd experiments and have people move in crowds without the risk of spreading COVID-19. And for that reason, I actually have two students studying this exact phenomena. So the two students, they will do experiments this semester where they will have people move in a crowd through an exit, and they will give them different instructions regarding sort of distance keeping. So they will look at what is used around the world. So what type of recommendations are you giving people? And then they will do experiments in the lab where people are told these instructions, like try to keep 2 meters away while you're evacuating this room. And what we're expecting that this will show is that the flow through exits will decrease as people keep a distance. You're basically changing the fundamental diagram, the correlation between speed and density. So the further the distance to the people in front, the lower the flow through the exit, hence the longer the evacuation times. And as I said, you can't really today, due to COVID-19, do these experiments in many countries. But since we haven't had a case now for a couple of months in New Zealand, life here inside New Zealand is returning to normal. So we can do these types of experiments. They're still simulated experiments. since one of the issues is you can't really, when you have the social distancing, the physical distancing in place, you can't do experiments with a lot of people since you're increasing the risk of spreading the disease. Here in New Zealand, we don't have that risk. And the only way we can influence people is to give them those instructions. And there is some weaknesses. They might not adhere to it, but at least we can see what the distance keeping is depending on what instructions we give. So things like telling them to keep 2 meters away at all times and then evacuate a room. We might even say, keep 2 meters away, but have the masks to see if they are closer when they're wearing masks, but given the same instructions, to see how that influences the flow through an exit, which will eventually influence the total evacuation time of buildings.
Yes, well, that relates with my next question that I had here, because you jumped from pedestrian dynamics to emergency evacuation, and this 1 month ago, I was speaking in a webinar on COVID, and we discussed that, and some of attendees made a very interesting remark. We covered already the impact of the social distancing, but there are other related aspects like use of mask, if then can give you some level of confidence that you can more easily or safely walk inside a smoke environment and then eventually risking yourself walking in a corridor that, for instance, you shouldn't. So how can this impact not only the social distancing, but all other things?
It could potentially do. We don't, I mean, this is all so new to us, so we don't really know what type of influence. The only thing slightly similar that I've seen is the sort of in road tunnels where it has been known that people have been staying in their vehicle, thinking that their vehicle will give them some form of protection from the smoke. And in some fires, and many fires, that has resulted, it's a fatal strategy, since it protects you for a while, but not for very long, as the tunnel fills with smoke. So it could be that you do the same type of assumption, that you have some level of protection, hence you think you're safer than you actually are as you're moving through smoke. But it is very hard to say, but it's not unlikely that people make that association.
Okay, another one now concerning emergency notification systems. What are the trends for the next decades?
I think we're moving into an era where we're looking a lot at smart systems and smart buildings. Emergency notification, that would be, sometimes we call it a bit, it's not correct, but we call it sort of smart signage or intelligent signage. Signage that changes depending on where the threat is, and it guides you the safest way out. This could be linked into a whole smart building system where you monitor where people are, you guide them in the most optimal ways out, which requires emergency notification and way guidance system that is able to do that. So I think we will see a lot more research in this space to look at these way guidance systems and notification systems that are a bit more advanced than what we see today. So examples of things that have already been started to be explored is notification from your mobile phone and way guidance from your mobile phone. So I did one study with a PhD student, Axel Mossberg at Lund University, looking at sort of could you get guidance on your phone to make you find your way out through smoke, and also notification. So we get pretty much all our information today from our mobile phone. Why not get the evacuation message on our mobile phone if we are inside a building?
Yes, once again, you are ahead of my question.
Okay.
This one was the next one, and I think you pretty much answer all the things. If we can use it have an app with augmented reality and show the best way and move us in the smoke environment.
Yep.
How long do you imagine that this can be done? Because I think there is some reluctance in some countries in Europe concerning like apps related to COVID, because they will get your data. And I think these apps will only work well if everyone has it and use it to get major data. So how long do you think it can take for this to be real?
It's hard to say. I think the technology for doing it is there already. The research to see how to design these types of systems has begun to be done. So there are a couple of studies where you looked at this. I think one of the problems and one of the issues and one of the challenges is to get all the systems talking to each other. So it's more of an engineering challenge. I think we can do it today, but it's a matter of someone daring to take the first step to design a smart building or a smart tunnel where you download the tunnel safety app, for example, which logs where you are and gives you instructions depending on where you are in a tunnel. As an example, when I was still at Lund University, we were working with the Norwegian Road Administration, since they're updating a lot of their tunnels. So in many of the tunnels in Norway, they don't have a lot of safety systems, and they don't have a lot of traffic in many of these tunnels. But one thing that we suggested in a report for the Norwegian Road Administration is exactly what you're talking about, apps for way guidance. So you get quick notifications. So if they don't have an alarm in the tunnel and you have the road safety app on your phone, then you get a notification. And then as you're moving in the smoke in the tunnel, you get way guidance as well to know which way to walk out. When it comes to how long it will take, I guess it depends on how quickly the road administration wants to implement these types of systems. I think the place it will be implemented first is probably in big infrastructure projects like metros around the world or big road tunnels. And it's a matter of just how quickly it's introduced in those types of projects, and then it starts spilling out over buildings as well. But I'm really difficulty predicting how quickly that will it will happen. I mean, the technology is there. It's just a matter of people wanting to try it out and see if it works. And the research is there, part of it, to see how these systems should be designed.
Okay, now a question from attendee. How can culture, heritage can influence the behavior of people in situations of evacuation?
It can definitely influence. There are a couple of studies already on this, where they did, the one that I remember is when they did evacuations of schools in Japan and Brazil, I think. Rosaria Ono, I think, was the author of that, if I remember correctly, where they did similar evacuations of schools in different countries, and they saw completely different types of behavior. Japanese was very, very structured, as far as I can understand. Sort of the kids lined up, waited for their teacher, followed the teacher, versus the Brazilian was more sort of the alarm went off and the kids sort of got ready and got out quickly. So it can definitely influence how people behave. It also things like distance keeping, like your comfort space will influence how you move in crowds, for example. So in many Asian countries, at least pre-COVID, people can, without feeling uncomfortable, they can be closer together. Versus if you look at New Zealand, Sweden, the US, you like to keep a bit of a distance. So that influences the flow through exits, for example. So you can get a quicker flow in some countries than other countries, which is partly due to the height, since the shorter you are, the more people, and the smaller you are, the more people you can get out through an exit, but also how comfortably or how close you keep to people and how comfortable that feels. So if you want this longer distance, it will also take longer time to evacuate a building.
Okay, so in Lund University, you have been awarded as the Teacher of the Year in 2018. So my next question is, what makes a good fire safety engineering professor?
So the teaching part, you mean, or everything?
Everything.
Everything. Okay. Well,
Because
yeah,
that's not only the teaching part that's important, but also the research part, of course.
yeah. Well, the teaching part, I think it's much about trusting the student. So a lot of my teaching philosophy is related to giving students responsibility, trusting the students to deliver, and sort of handing over the responsibility of problems to students. Since you can motivate people to do a lot of things if it's clear to them that I trust you to find out what's true or find out the answer, and I trust you to find a good answer, and often giving them answers that you don't necessarily know the answer to yourself. So giving them a responsibility to explore something, that is sort of what drives me in my teaching, and what I try my students, and how I try to engage my students. But what makes a good professor? I'm not sure I am a good professor, but there's also
at least you have been awarded as one.
No, but from the teaching perspective, definitely that. I mean, in academia, as always, you have the three parts. You have the teaching. You need to be an effective and a good teacher. You need to be a good researcher, not just sort of repeating what has already been done, by sort of thinking about new stuff and introducing new stuff. That's an important thing. And then the final thing I would say is communicating it. Since you can be really, really good at doing research, really, really good at teaching, but if you don't communicate with the wider society what you've learned, and the fire engineering community, it doesn't really matter. So getting the word out there is also very, very important, I think.
Okay. So I have another question from Guillermo Hein. What are the biggest differences in fire safety engineering that you see between Sweden and New Zealand?
They're, surprisingly enough, they're quite similar. The approaches used in Sweden and New Zealand, probably since they did performance-based design. They introduced it at approximately the same time. They also, a couple of years back, both Sweden and New Zealand sort of realized that there were too many degrees of freedom. So you could basically do performance-based design any way you wanted. And not everyone, but there are cases always of people misusing it. So what the government did, or the building regulators did both in Sweden and New Zealand, was that they took it back one step, and they introduced a very specific sort of verification guide with specific scenarios that you needed to follow. And they did this at approximately the same time to tell the fire engineer, these are the minimum number of scenarios you should consider. So here in New Zealand, it's called CVM2. In Sweden, it's called BBR-AD. Slightly different approaches, but the same type of principle. So I would say they're actually quite similar. So even though I've moved to the other side of the world, it is not that different between Sweden and New Zealand.
Yes, but eventually, I'd say that New Zealand and Sweden are two countries that are leading the performance-based design, and in the rest of the world, there are countries that are far behind than other, like UK, the Nordic countries, UK, I would say Singapore, they have very up-to-date performance-based design codes. But there are countries that, they are far behind. So that is my next question. Thermodynamic, fire chemistry, those are universal. Why there are so different codes around the world?
It's a very good question. I'm not sure I have. I'm not sure I have the answer.
It's not the first one that I ask this question.
Okay. No, I think the codes, and I can relate this to the work that I do in standards development, since standards is sort of similar to codes, I guess. And a lot of standards development you base on research, but then there is an element of sort of what have we done in the past and how much can we change based on what we've done in the past. And it's the same with codes as well. As you're developing codes, you might want to change the code, but it's seldom that you sort of rip the code out and say, we're going to change everything in the code and do it completely fresh. So you sort of keep things from the old code and you modify it step by step. So codes in different parts of the world have evolved from what they were 100 years ago, maybe, to what they are today. And it's sort of a stepwise, since you can't really do a revolutionary change of a code, since then you get it's too dangerous to do that. So you do small and small steps. And most likely the codes in different parts of the world have probably diverged a bit and taken different paths.
Yes, and eventually, do we have as much science and technical knowledge in codes as we should, or most of them are more empirical and a result to major problems with fires? So
yeah, no, I mean, their codes in most parts of the world are changed based on something that happens. So if you have a disaster, for example, then you change the code to address that problem. And then depending on what disasters you had in that particular country, your code might shift in one or the other direction. But you do also get a fair bit of science in when you develop codes. Like the example now is the revision of CVM2 in New Zealand, for example, where MB, so the building authority, they're actually seeking experts in research to provide input for the new version of the code. So a number of academics at the University of Canterbury are involved in reviewing the numbers, like the pre-travel activity times, to see that they're still relevant. And that is based on research. So you do have an element of consulting research and trying to get research in. But at the same time, as we said before, it is also a matter of not totally changing the code from one revision to another, since that would upset the engineering community too much, and it might also lead to you missing quite a number of things when you introduce the new code. So that's why it's sort of changed in stages. But I would say that at least some building authorities do take in research. And I know of a number of countries where when they review the building code, they try to get academics involved to get the latest research. And it might not be the research frontier, but at least the established research to get valid data into the codes and valid assumptions into the code.
Okay, so and another topic that nowadays is there's a lot of discussion about it, are facade fires. Mm-hmm. Theoretically speaking, they don't have a huge impact in evacuation, but the fire spread can eventually. Some buildings are designed for a phased evacuation. If you have an uncontrolled facade fire, you will have not a phased evacuation as the building was designed. And if we look to the detection time and the reaction time, well, it can be a little bit longer. And eventually this isn't as studied as it should. So do you have any comments on this? So the relation between facade fires and evacuation?
It's nothing I've studied, and I don't know if anyone has studied it. But as you say, it's sort of when you have a facade fire and it's a facade fire alone, it is mainly a property problem. If you have a facade fire and other problems in the building at the same time, a facade fire can definitely create evacuation problems as well. So, I mean, if you look at the what the fires that have occurred. There are some facade fires which are just an external fire. And then you have fires that have led to smoke spread inside the building, and then it becomes an evacuation problem. But as I say, I don't know of any study specifically looking at the impact of facade fires on evacuation, although you could imagine that the more recent facade fires that have had disastrous outcomes probably at least has changed people's perception of the safety of high-rise buildings. So we did see something similar after we had the Gothenburg nightclub fire in Sweden, which was a major disaster in Sweden. And the series of experiments that were done post the year after, we typically had people responding much quicker for at least a couple of years. So it will probably and most likely have influenced people's mindset and their willingness to evacuate, and how if they take high-rise fires more seriously or not.
Okay, so I would say that my last question is, what are the challenges we have ahead of us concerning evacuation, and what topics should we invest in our research and to be able in future years to pass this knowledge to the codes?
I would probably highlight three areas. If I think about it, I think three areas. I would like to see more research in the area of smart buildings and smart signage. As we mentioned before, there is a huge potential looking at the mobile phone guidance and those types of things. And also monitoring of people in buildings to know where they are and if they've evacuated or not. I think we're not yet brave enough to implement it in buildings, but I think with a bit more research about smart buildings and guiding of people and monitoring of people, we could do our first proper smart building from an evacuation point of view. We already have smart buildings for energy, but we could do a smart building for evacuation that guides people the safest way out. But that requires a bit more research in that area. I would also like to see a bit more research in the area of evacuation elevators. Evacuation elevators, they're allowed in some codes, but rarely to replace a staircase. So we're typically required to have 2 staircases. And then if you want an evacuation elevator, you need to do that on top of the staircases you already have. It's a relatively bold idea, but why not convert the elevators to evacuation elevators and replace a staircase instead? I know there are building codes that for some building heights require 3 staircases, and then one of them can be exchanged for an elevator. But we should start doing research on, could we take out one of the typically 2 required staircases, replace it with the elevator and make it an evacuation elevator, and still achieve the same level of safety. Now, this requires us to know how to guide people to the elevator, how to communicate that it is as safe as a staircase, and we can make it, I believe we can make it as safe, even safer, if we use the right systems. And in many buildings, like a 50-floor office building, for example, if you use the elevators, we can actually get a quicker evacuation if we get people to use them. So it seems to be the sensible solution, but I think in many codes, they haven't dared to take that step to allow you to take out a staircase and introduce an evacuation elevator. So a bit more research in that area. The final area is pedestrian dynamics. Since we've been using fundamental diagrams for a very long time, but a fundamental diagram is basically a bunch of data in a graph, and then you sample from that data and you try to put it into your models to get realistic crowd movement. What we've started looking at is instead biomechanics of movement. So we've looked, rather than just getting the speed as a function of interperson distance, we look at how people interact in a crowd. So what is the step length? How does the step length influence or change as you move closer to people? How does the height of a person and their leg length influence the distance they keep to a person in front? And a lot of this research can explain why we have different fundamental diagrams in Japan, where the height is the average height is much shorter than in the US, where we have a different fundamental diagram. Now we're just treating it as we're getting one fundamental diagram from the US, one from Japan, one from China, one from Sweden. But if we could get a fundamental model describing how people move, we could just tweak the height and get information about how people move if they're 150 rather than 2 meters tall. And this requires us to understand how people move and interact in crowds. And we've started doing some research in that area, but we're not there yet. And that requires a huge research effort, since it's a lot of experiments to understand and a lot of precise measurements of movement to be able to understand how people interact in crowds.
Okay. Well, Daniel, it was a very, very interesting chat.
Thank you.
Thank you so much.
Thank you for inviting me.
This is our last chat before summer vacation. Well, it's summer now in Portugal. And in August, we won't have any chats. But in September, we will start to have. And meanwhile, I will send you a message telling who is the person to be interviewed for you to make 2 questions, okay?
I'll make 2 difficult questions, I promise you.
Hope so. Well, I would like to thank everyone that is attending, and not only in the live broadcast, but also afterwards in the recording that will be available. Daniel, once again, thank you so much.
Yep, thank you for inviting me. Thanks.
Bye.
Bye.